Okay, so we're recording, and hold on, there we go. Yeah, we're recording, and we're talking about the recap of the 2.4 notes. So let's look at examples 4, 5, and 6. So example 4, you're asked to find the slope of the curve at x equals 2. So all you really need to do, I won't say all, but you're using this formula, the limit h approaches 0 of fa plus h minus fa over h. This is the big formula that's going to define this whole semester. A represents the x coordinate for where you're finding the slope of the curve, or the line of tangency, if you want to think, or the point of tangency, if you want to think of it that way. So you're going to replace a with 2, and of course your function is x cubed minus 2x. You plug 2 in, you get 4. That's real easy. Plug in 2 plus h, that's going to require a little bit of algebra. Be very careful with the algebra. And that's actually what kind of happened. Some people missed a few points on the test that we had last week. On number 11 of all those limit problems, some of the algebra was a tad off. If you're not sure where you made your mistake, just find me during office hours or shoot me an email and I'll give you some feedback. But anyway, and I am going to go over it anyway during this class, so you'll have that regardless. So yes, you go through the algebra here, cross stuff off. Constants should cross out. If your constants are not crossing out, you made an algebraic error, because you want just alternative h up top, so you can pull it out and cross off at the bottom. Trust me, these problems are done deliberately with the h crossing off. If you're not getting the h crossing off, you probably made a mistake with the algebra, or maybe it's your setup, I don't know. And then once that crosses off, then plug in 0 for h, and you get 10. That's going to be the slope of the tangent line. To find the equation of the tangent line, that's easy. Just use point slope form. Y minus y1 equals m times x minus x1. Your x1 and y1s are 2 comma 4, because remember, we're doing this at x equals 2. The y value that goes with that is 4. And of course, to do the normal line, you do the negative reciprocal of the slope, right? Negative 1/10. So that should be pretty easy. So we're good there. Okay, example 5 is not shown. You do the same thing. Yeah, shoot, I thought this was filled out. That's okay. I'm not going to do it from scratch. Actually, maybe what I could do is if I go to the YouTube playlist, let me go back to Schoology. So again, the YouTube playlist is right here. Okay. And if I click on that, hey there, I'm going to silence that and just skip ahead. Yeah, so this will be a good workaround. So you can see what I did here. You got to plug 5 in for the function and 5 plus h. Again, it's 1 over x minus 3, so be very careful there. You have an LCD of 2 times 2 plus h. Combine the fractions. H on the bottom is h over 1. Flip it. H's should cancel. Then you can plug in 0 for h. You get negative 1/4 for that one. And that makes sense. If you were to graph that function and draw the tangent line, it does look like it has a negative slope that's not too steep. If I skip ahead to example 6, and this is kind of working backwards. You're given the slope. You got to figure out what a is, right? That's what you're trying to do here. And I kind of made a mistake because I thought initially we were doing this at x equals 4. That was my mistake. I made an error there. Anyway, the slope is 4. So f of a, that's easy. A squared minus 3a plus 1, a plus h. That's going to be a lot of messy algebra, but you got to go through it. Again, anything that doesn't have an h should cross off. Everything that's left up top should have an h in it. Pull it out, cross with h on the bottom, then plug in 0 for h, and you should be okay. And then part B, I think I did a little bit later. Part B, if you have a 0 slope, that means it's going to be at a peak. So it's actually going to be at the vertex. And that's something we'll talk about often. I don't know why it's not playing. Oh, there we go. I just made like some corrections really quickly and I got 1.5. So you didn't have to redo the whole thing. You could just sort of use what you had before. But of course, replace the right side with 0 instead of 4, and you're solving for a still. Okay, so that recaps that. Let's look at the Google form really quickly. Close that down. Okay, Google form. Look at some of your responses so far. So why do we call the slope of the secant line the average rate of change? The slope of the secant line is the average rate of change because of the slope between 2 points of a curve. The change y between the 2 points over. True. We have 2 points. You find the slope. Just remember, the secant line is a line that passes through 2 points on a curve. You just find the slope, and that's what we call the average rate of change. And again, you're just on average finding how y changes with x over a certain interval. Now for number 2, why do you call it tangent instantaneous rate of change? It's at a particular moment or a particular point. So this is a good response. The slope of the tangent is also called instantaneous rate of change because as a horizontal distance between 2 points reaches 0. So remember, we had like a and a plus h. So that when that difference became pretty much 0 and they were virtually the same point, we can find the slope of the curve at a single point. That's exactly what's happening. So it's at a particular moment we want to see how fast something's changing. So that's what we call instantaneous for that reason. How do we use limits to find the slope of the tangent line? So basically, you do the limit, right, between f of a plus h and f of a. And right, you're kind of assuming that h, the distance between the horizontal distance between the 2 points, is getting closer to 0. Yeah, it's only because h can only approach 0, not actually be 0. Right. This one here, for 2 over x at x equals 1, I believe the answer was, hold on, I'm trying to read that carefully. Let me work that out very fast. So this might be good for us to do really quickly. So 2 over x, 1 plus h minus 2 over 1, because remember, it's f of a plus h minus f of a over h, and there's a chat. Oh, no worries. Welcome, Michael. So you have this, right? And then the LCD is going to be 1 plus h. So multiply that by 2, 2 plus h over 1 plus h, all over h. And if you work it all out, remember that's 1, sorry about that. So you should get negative h up top, 1 plus h down below. Times 1 over h. As h approaches 0. I think I'm doing this right. So you should get negative 1 over 1 plus h. So slope should be negative 1. Oh, it's 27 people that said that. Okay, hold on. Got it. Okay, I was just confused. I thought 27 was the answer. But if you plug in, if you plug in 0 for h, you should get negative 1 as a slope. I'm pretty sure that's, let me just do it really quickly. 2x to negative 1 power. No, it actually is negative 2. Then what did I do wrong? Oh, do you guys see what I did wrong? Anyone want to say that's what I did wrong here? It is negative 2. I wouldn't suspect that half the class would be wrong. Your teacher was wrong. Well, it is negative 2. What mistake did I make? Can anyone see what I did wrong? Did I forget to distribute? Yeah. Should have been negative 2h. So it is negative 2. That's correct. So that's number 4. Yes, and the mistake I make is that for the last example, example 6, I assumed that was at x equals 4, not the slope of 4. So anyway, we're 0. All All right, so that's enough for the recap. Homework, again, there were some textbook problems. I'm gonna do it at the back half of class. So let me actually start doing a live lesson with you guys. So I'm gonna now, reviewing the test, I'll do that during the homework review at the end. So I do wanna get the live lesson started. So let me go and clear my drawings. Let me go ahead and pull up these notes. Okay.